Experiment number 6 to develop dynamic programming method for unit commitment using MATLAB software. Okay, now in this practical we have to need dynamic programming method by using MATLAB software. Okay, now this is the theoretical data is here and this is the AM. Okay, now we have to require MATLAB software. Okay, now this is the system consists of 4 thermal generating units. That means here we have to use 4 thermal generating units. Okay, now here we have to need to calculate most economical units have committed for load is 9 megawatt. Okay, now we have to using dynamic programming method. These are the 4 thermal generating units. Unit 1, 2, 3 and 4. And this is the capacity of generator. This is the minimum capacity and this is the maximum capacity. Okay, now here we have to require minimum capacity is 1, 1, 1, 1 and maximum capacity of thermal generating unit is 12, 12, 12. Okay, these are the maximum capacity and this is the minimum capacity and this is the cost of thermal generating unit is here, that is A. Now this is the 0.77, 1.60, 2.00 and 2.50. Okay, now this is the second column is depends on cost. That is, these are the 2 tables we have to require. Okay, now this is the given problem and this problem available in Modern Power System Analysis DP Quadrant. Okay, now this is the problem is here. Now we have to require solution. That is, we have to require program. Okay, now this is the program is here. That is, these are the command. These are the values we have to require. Here alpha, it will be given on here. That is, these are the values of alpha. This is the values of beta. That is given here. This is the minimum generating power. Okay, that is 1, 1, 1. And this is the maximum generating power is 12, 12. That is given here. Okay, now this is the minimum power, maximum power. Okay, this is the minimum cost and maximum cost. We have to consider here is A column, B column. Okay, now here we have to need most economical units. Its power is 9 megawatt is given here. Okay, now this is the way of consider initial cost is 0. That means we have to require initially thermal generating unit is 0. Okay, now we have to require here we have consider this is the iteration. Okay, that is I, J, K. That is we have to require thermal units. Now first we have consider the value of I is less than generating power X. Okay, J, K and 1. These are the we have consider 4 samples or 4 thermal generating units. Okay, now we have considered unit 1, 1. Okay, now this is the formula of cost is here. This cost is equal to cost plus 0.5 alpha I square plus beta I. Okay, now this is the we have considered formula is here. This is the for unit 1, 1. Then we have considered second unit, that is unit 1 to 2. That is, this is the I, J, K. Okay, now this is the 4 thermal generating units, that is I, J, K. Okay, now here we have considered unit number 4. This is the formula for here. Okay, now this is the given data. It will be given in our problem. Now we have to calculate cost. Okay, now we have to calculate cost minimum cost of thermal generating unit. Okay, this is the given program is here. Okay, then we have to consider display how many number of units used in here and how many number of power generated is here. Okay, now here we have consider output is here. We have consider here, this is the output of thermal generating unit. It is cost of thermal generating unit is 7,200. Okay, now this is the output of this program. Okay, now here we have need MATLAB software. Okay, now this is the MATLAB software is here. Then we have to need new script. Okay, now we have click here new script. Okay, now we have to need this program. Okay, now here we have to copy. Okay, remaining program on next page. Okay, now click on run. Okay, then we have to need save program. It is dynamic programming method. That is we have save DPM. Yes, save. Add to file. Okay, now here the output is generated is here. It is n is equal to 9. We have considered the output is here. Okay, now this is the program of this is the total cost is we have to calculate.